Hello everyone, my name is Preeti. I'm a registered nurse. In today's video, we will gonna learn about ABG interpretation. So let's get started. So let's learn about ABG interpretation. So before we jump into ABG analysis, let me give you a little bit overview about which method we will use to decide whether this is respiratory or metabolic. So we will gonna use a row method, respiratory opposite metabolic equal. Now, whenever you think about respiratory, connect that with CO2. And whenever you think about metabolic, connect that with HCO3. Respiratory opposite. So what you are comparing with pH. So CO2 and pH will go in opposite direction. If CO2 is high, then pH will be low, that's respiratory. If CO2 is low and pH is high, so that's respiratory. They both will go in opposite direction. One is going higher, one will go lower. When we are talking about metabolic, think about HCO3. Equal means they're both going into the same direction. If HCO3 is high, pH will be high too. If HCO3 is low, then pH will be low too. So let's look here at this table. CO, CO2, so if CO2 is greater than 45. Now compare with pH. If pH is less than 7.35, pH is going into the lower direction, less than 7.35. CO2, which is greater than 45, opposite direction, respiratory opposite. So we have a match in respiratory system. For metabolic, they both will go in same direction. They both pH and HCO3, they both will be low or they both will be high. So let's look at here. If bicarbonate is less than 22 and if pH is less than 7.35, they both are going in same direction, means we have a match in metabolic system. Even you can look at the arrows. Here pH is going into same direction, LCO3 is going the same direction, same color, it's a metabolic problem. Opposite, one is going down, pH is down, CO2 is going up. So we have a match here, opposite respiratory system. So let's learn more with the example. So step 1, whenever you have any value, follow the steps. The number we have is our pH is 7.25. CO2 is 55, HCO3 is 25. Now it's very important that you should know the normal value of these three, pH, CO2 and HCO3. So for this example, we have here pH which is 7.35 to 7.45. That is our pH. What number we have here is 7.25. So if you see number 7.25, which is less than 7.35, so pH is going into the lower direction. So if the pH is less than 7.35, this is acidosis. Now we already decided this is acidosis. Now we will decide whether this is respiratory problem or metabolic problem. That is our step 2. How we will decide? So let's look at the second value. CO2 is 55. The normal value of CO2 is 35 to 45. So CO2 is greater than 45. So that is the value is high. So we got the match here. pH is going in lower direction and CO2 is going into the upper direction. Respiratory opposite. So this is a respiratory problem. So respiratory acidosis. If you look at bicarbonate, which is 25. So our normal value of bicarbonate is 22 to 26. 25 is normal, so we're just gonna write N here. So we decided this is respiratory acidosis. Now, whether this is compensated or uncompensated or fully compensated. So step 1, look at the pH. If your pH is normal, within normal range between 7.35 to 7.45, it's fully compensated. But here our pH is not normal. pH is less than 7.35. So pH is abnormal. Second step, look at CO2 and bicarbonate, whether they are normal or abnormal. So one of the value here is normal. HCO3 is 25. The normal value of HCO3 is 22. to 26. So HCO3 is normal. Means the kidneys are not trying to compensate. So this is uncompensated. If any of the values CO2 or HCO3 is normal, means the opposite organ is not trying to compensate. So this is uncompensated respiratory acidosis. Let's go with our second example. So here we have pH which is 7.55. So let's decide whether this is acidosis or alkalosis. Our normal pH is 7.35 to 7.45 and pH is greater than 7.45. So which is alkalosis. So we're just going to put the arrow here that pH is going on higher direction. So that will going to help us to decide. So we have decided this is alkalosis because pH is greater than 7.45. Now second start, whether this is metabolic problem or respiratory problem. So let's look at CO2. CO2 is 49. The normal value of CO2 is 35 to 45. CO2 is greater than 45. So that is going into the higher direction. So if this is a respiratory problem, these will both go in opposite direction because we say respiratory opposite, but these both are going into the same direction. So there is no match in the respiratory system. Now let's look at the bicarbonate value. HCO3 is 35. The normal value is 22 to 26. This is greater than 26 means it is higher. So here we get the match here in the metabolic system. pH and HCO3, they both going in the same direction, equal, so metabolic alkalosis. Now let's decide whether this is compensated, uncompensated, or fully compensated. So let's look at the pH first. Is the pH normal? Normal value is 7.35 to 45. Our pH is 7.55, so no, pH is not normal. Now look at further two values, CO2 and HCO3. They both are abnormal. So all three values are abnormal here. So there pH, CO2 and HCO3, they are abnormal, means this is partially compensated. This is a metabolic problem. The lungs are trying to compensate, but this is not fully compensated because the pH is not normal. They are not successful to bring the pH in normal. So this is partially compensated. All three values are abnormal, partially compensated. They are trying, but it's not fully compensated yet. So our answer is metabolic alkalosis partially compensated. Let's move on to our third analysis. So pH, here we have pH is 7.37. So let's decide whether this is acidosis or alkalosis. Now this is little tricky here because pH is normal here. So what we will gonna do? How we will gonna decide whether this is acidosis or alkalosis? 7.37. Our normal pH is 7.35 to 7.45. So this is normal pH. In this situation, when you have a normal pH, put 7.40 in the center. If it's less than 7.40, then that is acidosis. If it's greater than 7.40, then this is alkalosis, right? So here, this is less than 7.40, we have 7.37. So that is acidosis. Now, this is respiratory problem or metabolic problem. So let's look at the second number. CO2 is 52. So this is respiratory or metabolic problem. 52, the normal value of CO2 is 35 to 45. Greater than 45, so this is going into the higher direction. pH is low, CO2 is high, so we get the match here, respiratory opposite. Why I say respiratory? Because CO2 is 52. pH is 7.37, which is going into the lower direction. So we got the match here in the respiratory system, respiratory opposite. So this is respiratory acidosis. If we look at the bicarbonate, which is 32, a normal value of bicarbonate is 22 to 26, which is greater than 26, it's 32. So if this is a metabolic problem, pH and bicarbonate will go in same direction, but this is not going into same direction. This is opposite. pH is low on acidic side and the bicarbonate is on alkaline side, is greater than 26. So we have no match. Let's look at the third step, whether this is compensated fully, partially, or uncompensated. This is very easy because we already know that pH is normal. So yes, this is fully compensated. So respiratory acidosis fully compensated. Remember guys, when you see CO2, think about respiratory. HCO3 metabolic. Compare that with pH. If pH and CO2 is going in opposite direction, if pH is high and CO2 is low, then that is respiratory problem. If HCO3 is high and pH is also high, metabolic problem. If HCO3 is low and the pH is also low, metabolic problem. They are both going into same direction. This is how we decide respiratory or metabolic. Always follow the step. Step 1, acidosis or alkalosis. If pH is less than 7.35, acidosis. If pH is greater than 7.45, alkalosis. Step 2, use the Rome method and see where you are getting the match. Step 3, compensated, fully compensated, partially or uncompensated. If pH is normal, it's fully compensated. If all three value are abnormal, it's partially compensated. Means there is a problem with one system, other system is trying to bring the pH normal. That's why all three value are abnormal, partially compensated. They are still trying, but not successful yet. Uncompensated if any value from CO2 or HCO3 is normal. If there is a respiratory problem and HCO3 is normal, means kidney is not trying to compensate. That is why uncompensated. Thank you for watching. I hope this video will help you to analyze the ABC interpretation.